We present ReMoS, a learning-based method that synthesizes full-body reactive motion of a person in a two-person interaction scenario. Our goal is to generate fine-grained reactive motions of a person for complex and dynamic contact-based two-person interactions. These reactions are derived directly from the 3D motions of the other person, also known as the actor, without requiring additional cues from text prompts or action labels. Two-person interactions have various applications in the field of games and entertainment media, social robotics, and interactive mixed and augmented reality, to name a few. Synthesizing reactive motions this way alleviates a common overhead for animators, enabling them to design an acting character and automatically obtain meaningful motions for a reacting character. Existing works on reactive motion synthesis generate reactive motions with limited synchronization. GANs used in the methods of Men et alia and Goel et alia synthesize reactions for day-to-day interactions, such as handshaking, hugging, or pushing. The transformer-based approach of Chopin et alia generates sparse-level reactive motions for pair dancing. Diffusion-based models such as Intergen, RAIG, and COM-MDM generates two-person motions from text prompts. In contrast, we focus to implicitly learn the fine-grained synchronization that is possible between two interacting persons just from one of the person's motions, without using any additional cues. With ReMoS, we focus on synthesizing both coarse-level full-body movements and the corresponding hand interactions to enhance naturalism in contact-based interactions, such as hand-holding between two characters. ReMoS is generalizable to a wide range of challenging two-person scenarios. It can synthesize reactions for the fast-paced swing-style Lindy Hop dancing. It can synthesize reactions for martial arts styles such as the Ninjutsu. It can synthesize reactions for different acrobatic movements, some kickboxing movements, and day-to-day activities such as hugging. Furthermore, our synthesized reactions show diversity. Notice that even though the two persons are holding hands, our method generates variations in the rest of the body movements. To explore two-person interactions in complex and diverse scenarios, we propose the ReMoCap dataset capturing full-body motions with finger-level articulations. The dataset captures interactive, challenging two-person motions in two scenarios: the fast-paced swing-style Lindy Hop dancing and the martial art technique of Ninjutsu. Now we look at some of our results. Qualitative comparison with the baseline methods show that our synthesized results react more plausibly with the given acting sequence. We see that the reactive sequences produced by the baseline methods often do not sync well with the acting sequence, whereas the motions synthesized by ReMoS are more aligned and plausible. For Ninjutsu, the reactor's movements need to match temporally with the actor for the interaction to be realistic. We see the arm motions synthesized in ReMoS match the positions of the actor well and create realistic interactions. In this pair dancing sequence, spatial and temporal synchronization between the two dancers is crucial. ReMoS here synthesizes more natural-looking interactions compared to the baseline. We show qualitative results on the character-character dataset, consisting of some kickboxing sequences. ReMoS synthesizes variations of reactions of either dodging or getting hit by the actor. We show a result of a two-person Latin dance from the interhuman dataset. ReMoS shows more arm and feet movements and twirls as compared to the baseline method. We show another result where two opponents are facing off in a boxing match. ReMoS synthesizes natural reactions to such motions as well. Same goes for the acrobatic movements from the ECCV dataset. We show a quantitative comparison with our baselines on the ReMoCap dataset. ReMoS achieves state-of-the-art performance on several evaluation metrics, discussed in details in section 5.3 of our paper. We further observe our performance with a user study, where participants have a strong preference for the reactive motions synthesized by ReMoS over the baseline methods, both in terms of motion quality and reaction plausibility. We further demonstrate a qualitative comparison with our ablated versions. One of the key components of our method is a combined spatiotemporal cross-attention mechanism that enforces coherence between actor and reactor. Without this component, we observe that the reactor's arm does not come in contact with the actor, which will result in hitting the actor back. We also observe that without using the spatial guidance at inference, the reactor's hand does not touch the actor's hand while defending from this attack. ReMoS can also be used as an interactive motion editing tool to control the reactor's motion in a given manner. We show result of a pose completion application, where we manually control the right hand wrist joint of the synthesized reactor, and the reactor's remaining body joints are synthesized automatically to complete the interaction with the actor. Another application shows that ReMoS can be used to synthesize the reactor's motion in between two given keyframes. In conclusion, we propose ReMoS, a denoising diffusion-based method for reactive motion aimed towards two-person interactions. ReMoS generates diverse, well-synchronized reactions for complex movements and plausible hand motions for contact-based interactions. Owing to the power of denoising diffusion models, we can use ReMoS to provide control to animators for motion editing applications. Finally, we contribute the ReMoCap dataset for two-person interactions with full body and hand motion data for future research. Thank you.